Let's start by enabling GPU in Blender. It is a very simple and easy step that a lot of people forget. Go to Preferences. Then in System tab, choose CUDA or Optics and select your GPU. Optics is newer and a bit faster. You can use HIP if you have an AMD graphics card, or you can use OpenAPI if you have Intel GPU. If your GPU is not showing in here, then there is some problem and you need to check your GPU's hardware and drivers. You can use CPU if you do not have a GPU, but it will be much slower. Also choose GPU instead of CPU in render settings as device. Enable GPU for denoising and compositing too. GPU is faster because the architecture of a GPU is different from a CPU. While CPUs typically have a few cores, GPUs have hundreds or even thousands of smaller cores. These cores work together in parallel, allowing the GPU to process a large number of tasks simultaneously. Most of the time, you will not need this much of light bounces in the scene. So you can change it to fast global illumination, but set it back to default if your scene is getting affected. The key point in understanding light bounces is that the number of bounces a ray makes is computed on the go, and the ray is going to be killed as soon as it exceeds one of its bounce quotas, so there is no clamping going on. 12 number of maximum light bounces should be enough for most of the scenes. Instead, if you are trying to render realistic caustics or something that requires a lot of light precision. But keep it under 8 if your scene is simple and it does not have a lot of reflection and transparent materials. Make sure to check the scene by rendering a frame, because if you set it to too low, then it could make the lighting very dull and will turn transparent material to pure black. Enable Fast GI approximation. It approximates diffuse indirect light with background tinted ambient occlusion. The render with Fast GI has a different look to it. It may decrease the quality of your render. So make sure to test it before enabling in final render. Enable persistent data under Performance section. It keeps render data in memory after rendering for faster re-renders at the cost of extra memory usage while performing other tasks. It will take extra RAM to store data. So if you have less RAM for the scene, then do not enable it. Increase the noise threshold. The noise threshold determines how much noise is acceptable in a rendered image. It is a measure of the error between the actual color and the sampled color of a pixel. Using it smartly will result in a very good and faster render, but bumping it to too high can result in noisy render. A number between 0.03 and 0.05 will be a sweet spot. Please like the video if you are enjoying and hit that bell icon to never miss a video. Decrease the max sample count. It refers to the number of paths traced for each pixel in the final render. Increasing the number of samples results in a clearer image and also increased rendering time, but after some point it does not matter. It just increases render time. Disable the caustics if you do not need them. Caustics is the envelope of light rays which have been reflected or refracted by a curved surface or object, or the projection of that envelope of rays on another surface. They look very nice, but they are very hard to render. It can significantly increase the rendering time. Make sure that denoiser is enabled because it will help to clean up the image. Denoiser uses advanced algorithms to remove noise from graphics and renders, making a huge difference to the quality of images. Photorealistic visuals and immersive renders are not possible without denoising technology. There are two types of denoisers in Blender: optics and open image denoise. Optics is an AI-accelerated denoiser that uses GPU-accelerated artificial intelligence to reduce the time to render a high-fidelity image that is visually noiseless. The denoiser is based on a paper published by NVIDIA Research titled Interactive Reconstruction of Monte Carlo blah blah blah. You can look it up on Google if you want. It will take a long time to explain here. Whereas Intel Open Image Denoise is an open-source library of high-performance, high-quality denoising filters for images rendered with ray tracing. Intel Open Image Denoise is part of the Intel Rendering Toolkit and is released under the permissive Apache 2.0 license. But basically, optics is better if you want to render animation, but Open Image is better in rendering still images. Optics is better in animations because it uses AI technology to produce same results every time by seeing previous and next frame, which does not produce weird artifacts. But Open Image Denoise can produce weird patterns in rendered animation because it does not produce same results every time, whereas it is better in still images. Tile size also matter a lot when rendering. You can find it under Performance section of Render Properties. It is kind of trial and hit method. You have to try different tile sizes according to your hardware, but generally GPU will be faster at big tile size, but CPU will be faster at smaller tile size. Go to Output Properties and change file format to OpenEXR. It takes much longer for PNGs to save after rendered, therefore it increases render time. But OpenEXR is much faster. It can decrease the render time by a lot if you are rendering an animation. Camera culling will cull any objects further from the camera than a given distance, which will decrease the rendering time. It only helps when you have a big scene and if there are a lot of objects in the background. If you do not want to do all this, then you can just download the Blender file from the link given in description. It contains all the setting you need to render faster. It will help the channel a lot. And thanks so much for watching. If you enjoyed this video and found it helpful, don't forget to hit like and subscribe if you want to see more content like this. If you got any questions or suggestions for future videos, drop them in the comments below. I'd love to hear from you.